this is force the line. Here's my idea. What we do is, we need 2 miles of relatively flat land, or it's easier if we use flat land. I'm thinking Oklahoma, Nebraska, Florida would work, but there's a lot of crap in the way in Florida. There's so much foliage here that we would need maybe, we could do this under power lines, but who really wants to work under power lines? So here's what we do. We set posts over a 2-mile stretch of land. What I've got here are my posts, okay? 10 feet on center. Here's your first post, second post at 10 feet, third post at 20 feet, all the way down to 2 miles, 2 miles away. Here's your last post at 10,560 feet, or 2 miles, and your second to last post at 10,550 feet, okay? I've got my break line in here to show that the distance between these 2 posts is 10,530 feet. You see what I've drawn here, okay? Now the idea is, everything is based off the first 2 posts. Okay. What we do, we set the posts in a straight line. Very, very easy to do. Contractors can definitely do this. And then between the very first 2 posts, we construct a beam between the 2 and level that beam. Okay. We level this beam. Okay. Make it level. This is typically how beams are constructed. You always level them out, unless there's a roof slope or something. But for a floor beam or something, you would always level it. Anyway, so this point right here is this point on the Earth, if we live on a convex sphere, okay? Meaning that when this beam is leveled, there is an imaginary line perpendicular to the center of gravity of the Earth, extending this to the center of the Earth. And then we do the same thing all the way to the end. We level each one of these beams all the way for 2 miles, okay? So every time you level one of these beams, it should be extending, it should be perpendicular to a line extending to the center of the gravity of the Earth. So over 2 miles, those beams will actually follow the curve. They have to. If a level works, the only way it can really work is on a sphere is if it works with the center of gravity. Okay? Then, what we do is we use a rectilineator type device below it to force the line. This very first beam we construct right here is perfectly parallel, or as close as we can get to perfectly parallel to this beam. It's leveled too. We level that beam, okay? But then for all of the rest of the beams on the forced line, as I'm calling it, we use a connection here. It forces this beam, it forces a right angle connection to the first beam, okay? So, say this is our first beam is leveled, okay? It's leveled out. The next beam that comes in, we use precision machine work, or like a CNC machine or something similar, to create a connection that forces a right angle connection to that first beam. Okay? So now, this second beam is not actually level. You wouldn't be able to tell from the naked eye, and if you put a level on it, it would probably still show that it's level because our levels are not that accurate. But it will stay in line with this beam. And we do that all the way down to the end. Now, we can just use a rectilineator type device. We don't have to build these beams. We don't need 1,057 of these beams on the bottom, because they're going to be expensive to make a right angle connection like this. You see I've got 90 degrees at all 4 corners. We can just leapfrog it and just mark the columns or the posts as we go until we get the line. Now, if the Earth is a sphere with a circumference of 25,000 miles, then over 2 miles, we should see from this point to this point a drop of roughly 32 inches. You can draw this in AutoCAD and prove it. This is what it has to be if the circumference of our world is 32 inches, or 25,000 miles. Okay? So, we go all the way down to the end. And this last post, we should have 32 inches between these two lines. Okay? Because over here we started at 64 to give ourselves ample space. And at the end, there should be 32 inches, roughly. It's not going to be exact. You know, there'll be some error, but there's enough. There's so much drop that is that any small errors and plumbness of these columns and everything shouldn't affect it too much. This could be 30 inches, whatever. Now, in the rectilineator experiment, they showed that the Earth curved up roughly 30 inches. That the concave sphere, it has the same circumference as the convex sphere. Now, that experiment was done 118 years ago, and nobody's done anything else like this since then. In fact, I find it funny that we don't have anything like this in the world. We have nothing that shows our curvature. Imagine how cool it would be to build something like this and leave it in place. Oklahoma, Nebraska, you guys want some tourism? Build this. Okay? Imagine driving in a dark sky area at night, and maybe they put some low lights, some lights that run down the line on this thing, and drive next to it, put a path next to it, or ride a bike or something. And as you're traveling, you can watch the curvature happen right before your eyes. You can watch these two lines converge. They will both appear to be lines to you, but one of them's actually a line and the other one's curving. Why don't we have this? Disney, I'm looking at you. Now you might argue, oh, it's just, nobody's going to spend money on that. It's just a waste of money to do something like that. We have pictures from space that show it's a ball. There's no point. Well, those pictures from space cannot calculate this curvature. They cannot prove the curvature. And on top of that, a few years ago, the United States federal government spent $800,000 on studying the benefits of snail sex. Seriously. Now, I'm all for studying our world, but I'm more interested, as a tax-paying citizen, in the curvature of my world than I am in snail sex. Snails, I ride my bike a lot. I'm out in the woods a lot. I see snails every now and then. They look like they're doing okay. I don't think we need to study their sexual habits. Well, we can study their sexual habits after we are proven that we live on this ball. I want to see this. I want this to happen so that I can rest easier at night and know that I'm not being lied to. So, let's force the line. I ran some rough numbers, and if we assume that all these members are 10 feet long, forgetting the rectilineator, just the top line and the posts, let's assume they're all 10 feet long, and that they're all structural steel, and they weigh 10 pounds per foot. Now, since this is outdoors, we're going to want to hot dip galvanize all of these shapes. Hot dip galvanized structural steel runs about 3,000 Fed notes per ton, a ton being 2,000 pounds. So, adding all that up, we need 1,056 plus 1 posts, so 1,057 posts, and 1,056 beams. You get around $317,000. That's a lot less than what we spent on studying snail sex. And we could do this cheaper too if we put some serious engineering work into it. They don't need the structural steel members weighing 10 pounds per foot. That's very conservative. We could make it better than that, but I'm just throwing some numbers out there. And then we also have to build this rectilineator type device, which then you could throw another $100,000 in there for that thing because it's going to take some very precision machining to build it. But we can do it. But who I'm really looking at is what about Disney? You guys have all that land south of Orlando. You've got Epcot Center with the Epcot ball that shows us it's a small world after all. Show us how small it is. Why don't we have this? Why don't we have this? I don't know. Let's force the line. Let's stop arguing about what we're seeing and measure it mechanically. Let's find our curvature or no curvature. You know, to be able to drive next to this and look up at the universe and shake your fist and say, hey, we're not so small after all. That's only 32 inches and 2 miles. What? We ain't that small, right? Are we going to see this? If we do this? I think this experiment would work. I've thought about this a lot. I don't think there's any real flaw in this. Please tell me if you see a flaw in it. But I think that this simple tool that we've been using for a very long time can show us the truth. Just a level. That's all we need, really. And of course, some precision machining to make the rectilinear type device. But simplicity is what's important. A simple way to measure the curvature. And we can construct these things all over the world. You know, Neil deGrasse Tyson is now telling us that we're not a perfect sphere as it appears from space, that we are an oblate spheroid, or more like a pear shape. Well, let's figure out how much of a pear we are. If we build these things across flat surfaces of land, I mean, you could do this in the mountains, you would just need really long poles. But if we built this all over the world, built these things all over the world and got our numbers and started comparing it and really kept building them over and over so we get really good at building them and improving the accuracy of the measurements, we could really get an idea of what our world is, of how much it curves. We could model it better. You know, globes probably, if it's an oblate spheroid, as we're told, wouldn't be a perfect sphere like this. We'd actually be able to show where it's not a perfect sphere, because we've measured it, we've done it, if this is it. Now, if the Earth is actually flat, then starting at 64 inches here, you would end with 64 inches here. There would be no drop, it would stay the same. If the Earth is concave, then you would actually end up with 64 inches plus 32 inches. The blue line would be up here somewhere, because it would show a curve up. Very simple. Let's do it. These governments around the world are just taking money from us and doing all kinds of things. You know, whether that money that was used to study snail sex really went to study snail sex, I have my doubts. Who knows? I work in the public sector, and I've seen enormous amounts of embezzlements and wastes of money, and it's just incredible to me. So, let's spend the money on something that would prove to us the world we live in, and I think this would actually bring humanity together pretty well. Every country could show off our curve. You know, curves so much in China, it curves this much here. How cool would that be? Disney, build this. Peace.
That is one big pile of shit.